Assalamu alaikum, dear students. Today we will solve some numerical problems which are from the NCRT textbook and are usually asked in the board exams. For class 12th, the very first numerical is a 4.5 centimeter needle is placed 12 centimeters away from a convex mirror of focal length 15 centimeters. Give the location of the image. That means we have to calculate the image distance. We have to find the image distance and the magnification. Then we have to find the magnification of this mirror. Then describe what happens and the needle is placed further from the mirror. We have to we have to describe what happens if the needle is moved further from the mirror. So we'll solve this numerical. Here a 4.5 centimeter needle is placed 12 centimeters away from a convex mirror. That means a 4.5 centimeter needle. So this 4.5 centimeter, it is the height, it is the size of an object, or we can say height of an object. Then we can write here object. So here O represents the object, that is equal to this O. It represents the height of an object, or we can say it's the size of an object, that is 4.5 centimeter. 4.5 centimeter. Now it's positive because it is above the principal axis, so we can here it's positive 4.5 centimeter. Then this this needle, it's placed perpendicular on the principal axis, but 12 centimeters away from a convex mirror. 12 centimeters away from a convex mirror. That means the objective distance is from the pole of mirror to the object. The distance is 12 centimeters. So we can represent it by U. U represents the objective distance. That objective distance is 12 centimeters. 12 centimeters. But here it is negative because it's on the left side of the convex mirror, so it's taken as negative according to the sign conventions. Then convex mirror of focal length 15 centimeters. The focal length. So we know that the focal length of this convex mirror, that is on the right side. That focal length, that is 15 centimeters. So we'll write here focal length F. So that is equal to 15 centimeters. But it is positive. It's on the right side of the convex mirror. So according to the sign convention, so it is taken as positive. So we'll treat it as positive. But we know that we have to calculate the image distance. V. We have to calculate V. So we can calculate by using the formula. That's a mirror formula. So that mirror formula is, we know that 1 divided by F, according to mirror formula, 1 divided by F, that is equal to 1 divided by U plus 1 divided by V plus 1 divided by V. So here it is we have to calculate 1 divided by V, or we can write in this way 1 divided by F here. So this will be minus times 1 divided by U is equal to 1 divided by V, or we can write here 1 divided by V, that is equal to 1 divided by F minus 1 divided by U, because we have to calculate the image distance here. 1 divided by V, then we take the reciprocal of this, so that will be equal to V. Here we can write 1 divided by V. So we can write here 1 divided by V. So 1 divided by V, that is equal to 1 divided by F. So what's F? So it is 1 divided by 15. 1 divided by 15 minus times. So 1 divided by U. So that is minus 12. So it is minus 12. We can write here 1 divided by 12. So then we can write 1 divided by V is equal to, so this will be 1 divided by 15 plus 1 divided by 12 plus 1 divided by 12. So we can write here 1 divided by V is equal to 12 plus 15 divided by, so it is 180. 12 into, so 12 into this 15, that's 180. Or we can write here 1 divided by v is equal to, here we can take 3 common, so it will be 4 plus 5, so 3 4s 12, so here 12, then it's 15 divided by, so 3 into, so here it will be 6 0, 3 6 18 0. Okay, so 3 and 3 will cancel to each other. Or we can write here 1 divided by v. This v, it is the image distance. It's the image distance. So image distance, that is the distance from the pole of mirror to the image. That's known as the image distance. So we can write here it is 9 divided by 60. 9 divided by 60. So this will be 3 divided by 20. 1 divided by v, that is equal to 3 divided by 20. 3 divided by 20. Or we take the reciprocal of this. So here we take the reciprocal of this, of v, that is equal to 20 divided by 3. So this is the image distance. So this is the image distance. So we can solve it further. So this will be 6 point, then again 20, that will be 6, again 20, so that will be 6. So v, that can be equal to 6 point. We can write it as 7 centimeters. 7 centimeters. Here the image, that will be the virtual image, because it's a convex mirror. So image, that will be a virtual image, virtual and erect image, that is behind the convex mirror, behind the convex mirror. So it was the first part. We had to give the location of the image. So the image distance, that is equal to 6.7 centimeters. Or we can write here v is equal to 20 divided by 3. Again we can write here, so it is v, v is equal to 20 divided by 3. Or we can write this or this. So 6.7 centimeters, that's the image distance. Then we have to calculate the magnification. We know that the magnification, that is the ratio of the size of an image to the size of an object. Then we can write here magnification. So that is equal to size of an image divided by size of an object, which is equal to minus u divided by v, or we can minus v divided by u, minus v divided by v u, or we can write here I divided by o is equal to minus v divided by u, minus v divided by u. So here I, that is the image divided by object. So here the object is, that is 12, object O, that's 4.5 centimeter. Here the object is size of an object. Here size of an image, we have to calculate the size of an image, but here O represents the size of an object. Also we have here 4.5 centimeter needle, that is the size of an object. So we write it as 4.5, that is equal to minus times image. So the minus times image, so v, that is equal to 20 divided by 3 whole divided by object distance, that's minus 12. So it's minus 12. Okay, so we'll write I, that is equal to, so this will be 20 divided by 3 into, so it will be 1 divided by 12, so minus and minus, so that will cancel to each other. So it will be I divided by, here it's 4.5, or we can write here I, that is equal to So, it will be 20 into 4.5 divided by 3 into 12, or I will be equal. Here it is 20 into. So 4.5. So the 4.5, it means 45 whole divided by here 10. 45 divided by 10. So we have 3 here into 12 into this. Okay. So this will be 10 twos 20. So 3 15s. So 15s. So it will be 6. It will be 6. So I here, I is equal to, so this will be 15 divided by 6. So it will be 2, 5. It will be 5 here, 3 5s 15. Or we can write here I, that is equal to 5 divided by 2, or I is equal to, so this will be 2.5 centimeter. 5 centimeter. So this is 2.5 centimeter. So I here is 2.5 centimeter. Now the next is, when the object is when what happens if the needle, that means when the object is brought further from the, when the object is brought further from the convex mirror, then what happens? So the image that moves towards the principal focus, that moves towards the principal focus. So it was the first numerical.